So I needed to switch off my own light. So here you can see the reflection of light. So what is a light? Light is wave particle. Light exhibits the property of a particle as well as a wave. Light is more like an arrow that moves like a wave or a thread, or you can say light is a thread that moves in the space. That's light. I'm saying just a simplified version. As per scientific version, they say it's photon, which has both property of a particle as well as a wave. Now there are some properties of lights. Let's observe. It travels in a straight line. The speed of light is 3 lakh kilometer per second, or 3 into 10 to the power 8 meter per second. Now light can be reflected and dispersed. Dispersed means it can go into all the directions. Wow! Light has both wave and particle nature. What is incident ray? Now on this mirror, this line, it's normal. This is angle of incident ray. And this is angle of refraction. So this ray is refracted ray. Which one is incident ray? Is it incident? No. This ray, and this ray. These are incident ray. And these are refracted. And this angle, if you consider this wave, then this angle here to here, this will be I, and this angle will be R. These will be always equal, both angles, angle of refraction and angle of reflection. Let's say this is a mirror. Here is an incident ray and here it's reflected. So this angle and this angle R will be always equal. So I always will be equal to R. The incident ray, refracted ray and normal all lie in the same plane. You see everything I am drawing on this screen itself, this whiteboard. So the whiteboard has a plane surface. I don't need anything 3D here. That is what it means by the same plane. If it was in 3-dimensional way, then it is in 3 dimensions, not on the same plane. And if it was just a laser, then it's a line, it's a linear object. Let's do this activity and find the different types of mirror. Easy. Which type of mirror is this? It's a concave mirror. Now let's have a convex mirror. This convex mirror. No matter how much I move the object in convex mirror, there is no real image and no zoom. Like you see, the image is always smaller. Whereas in the concave mirror, you see first when object is far, image is close and small. But when I take object closer to the concave mirror, the image is getting bigger. Now observe. What will happen if I take pencil far? It should get smaller, na? See, in this mirror, it's actually getting smaller. The more far I am taking, my entire hand will get smaller. See. Whereas in this mirror, the hand is getting bigger. Oh. What about this? Just a plain mirror. And it will have a lateral inverted image. Means what? Left, right, left. So the center point of the mirror is a pole. Center of curvature. So this point is pole. This is the focal point of the mirror. So this will be the center of curvature, almost double. And the original line from which this circle was made, that's the center of curvature. What is radius of curvature? The distance, this distance or this distance, let's say from here to here, the mirror is 2 centimeter, then it will be radius of curvature. Now principal axis, this central axis itself is the principal axis, principal focus, this point, this one is the principal focus. Focal length, this length from here to here, this is the focal length. Aperture, now always radius of curvature is double of the focal point. is double of this distance. It's 2f. If this is f.
Yes, sir.
Yeah, a few things are important. Let's observe those rules. Ray parallel to the principal axis always passes through the focus after reflection. This is the ray parallel to the principal axis, and see, it's coming through the focus, this point. Okay, so yes, it's working. Ray through focus becomes parallel to principal axis after reflection. Let's check that also. Here is this ray going through the focus, and yes, it's getting parallel. So yeah, that's also right.
Yes, sir.
Ray through center of curvature reflects back to the same path. Does it happen? We need the object to the center of, beyond the center of curvature. Oh yeah, see, observe here. This ray is got reflected here. This ray got reflected here. What about this ray? It got reflected back at the same path. And these are all meeting over here to form the image. So yes, that's checked. Ray hitting at the pole reflects making equal angles with the principal axis. So if a ray is going to the pole, let's observe the ray hitting to the pole here comes out at the equal axis. Okay, let's have a convex mirror. Now we have a convex mirror. In the book, the design will not be like that. Object will be always this side. Object will be always this side in the textbook. But here, for the sake of simulation, we are keeping the object this side. Now what is happening? You see, the biggest observation for convex mirror is no matter where is the object, image is always small and virtual. This ray is getting reflected as if it would be coming from here. That's from here, focus. Okay, so the parallel one. So yes, becomes parallel after. Ray directed towards the focus becomes parallel after reflection. Let's see that.
But how?
Observe this ray. It's going towards the focus. Okay. And after the reflection, it's coming parallel. That's the rule. Image formation by concave mirror. If object is at infinity, the image will form at focus. So let's do that. Now these lines are parallel. Let's have a concave mirror. So this point where these are all being focused, this point, that's the focus. Object is beyond C, then image will be between F and C, real and inverted. Now object is C, object is beyond C, C, far from C. Where's the image? Image is here, okay, and it is between C, center of curvature, and F. But if I bring the object at the center of curvature, you see, image and object both are of the same size. Okay, and if I take it, very important, if you understand this part, just keep in mind in the exam when you need to learn that at which position of the object, what will be the position of the image.
Yes, sir.
So always keep this position in the mind that at the center both are the same size and same height. But you see, this is ulta, real, but inverted. If I take the object far from the center, you see the image is coming close to the focus, and at infinite distance it will go on the focus. So when the object is beyond C, the image is between C and F. What will happen if I bring the object between C and F? Will the image become big? Yeah, see, it's becoming big. What will happen at F? See, it's infinitely large and it forms at infinity. And when you take it further closer, then see the magic. This is the magic of science. It's behaving like a mirror, and different kind of mirror. And here we are getting a virtual image. So keep in mind, this is a virtual and erect. Erect. It's not inverted, it's erect image. When when it's between F and P, the center point of the mirror and the focal point. So keep this in mind. This will help you to remember the thing and you won't get confused with the diagrams.
Oh.
So we just now learned this thing, that when at infinity it's a small, it's real and inverted, and it's at focus. Beyond C, between F and C, we just now observed, and real and inverted and small size. And in the starting I said, when the object is at C, the image is also at C, okay, and it's real and inverted and the same size. But it become bigger when you bring it between C and F, like center and focus. It will become bigger, enlarged. It will be virtual and erect at only one condition, if it is between P and F, like very close to the mirror, as we observed just now. So I will show the simulation. You can observe once again. When object is at focal point, the image will be infinity, real inverted, and infinitely big. Here highly enlarged, but actually infinitely big. So I will show that once again. Observe the different positions again. So when the object is at infinity, image will go to the focus here. When the object is coming close to the center, you see image is between where? C and F. Image is between C and F. When object is coming on the C, center of curvature, you see both are of the same size and real and inverted. But when object goes closer to the focus, it's between C and F. See, image is getting big, enlarged. And when you make it like on the focus, it's infinite. So the image is forming at infinity as well as it's highly enlarged. But if you take it further towards the pole, like more closer to the mirror, it will become virtual. You won't get a real image at all. It will become virtual. See, this is what we just now discussed. These are the position. If you keep this in mind, that's it. It's easy peasy. Image formation by convex mirror, there is only one situation. It's virtual and diminished. That's it. Now sign convention. See here, distance of object. Okay, distance of object will be like 8.7 and its sign will be minus 8.7. This direction is negative, minus, and from here this direction is plus. If the, let's make a virtual object, virtual image, and then you'll see the plus direction distance. Yes, so now this distance is plus, this one like plus 2.2 something like that, this distance here to here, and also this is also, height is also in plus. Now the heights, this height upward is positive, let's say it's 1.5, so plus 1.5, but this height downward is negative, let's say it's 2.5, so minus 2.5. And yes, that's pretty much it, the sign convention. Here also same will apply. Down, this downward distance will be like negative and upward will be positive. That's it. Now if we do some experiment, light shows some amazing and interesting phenomena. For example, we can have multiple inner reflections and so on. Observe, the more we are allowing its space, the more it is getting reflected. What if we have another similar mirror? Observe, like this the light is continuously bouncing and we got this nice pattern.
Wow.
By the way friends, if you forget to subscribe Best Classes channel, then you can search on YouTube at bestclasses.pandeysir. Till the next time, Bharat Mata ki Jai and best of study. And don't forget the famous phrase of Pandey sir, push past your limits.